Hi class, this is Dr. Karsten, and today I want to go over lesson 4, and this is from module 5, grade 4. So in this module so far, we have been working with fractions, and we have been modeling them with tape diagrams. We have been decomposing, and I want to remind you what decomposing means. So remember in English language arts, if you are writing a composition or an essay, you are taking lots of little pieces of information and putting them together into one piece. So you're writing a composition, you're composing. Well, in math, what we like to do is we like to sometimes take those things and we like to pull them apart into smaller pieces. And that's what we've been doing. We've been taking things like one whole thing and we've been decomposing it into smaller pieces, into fractions. Now, when we pull it apart, the things that we have to remember are that every fraction has a numerator and a denominator. And the denominator is the bottom, and it represents the number of pieces that one whole has been cut up into. And those are equally sized pieces. So it's the number of equal pieces that it has been cut up into or divided into. The numerator is the number of pieces that we have. So far, when we have been working, for example here, we have been bracketing off what one whole is, and often it'll be the entire tape diagram. Sometimes it'll actually be a piece of the tape diagram, and there'll be more when we have fractions greater than 1. So now if I were to look at this tape diagram, I can see that one whole has been divided into 1, 2, 3 pieces, which means that the denominator for each of these pieces, the fraction, would be 3. And since this is just one piece here, I would put a 1. I could also have said that I have 2 of those pieces. So that would be 2/3. Today, what's going to be different is that we are going to be bracketing off on top and showing 1/3 or 2/3 or 1/2 or a variety of different numbers. So we won't always be showing what one whole is equal to. And for this lesson, actually, one whole in general is going to be the entire tape diagram. The other thing I want to remind you of is that a unit fraction is simply a fraction that has a 1 in the numerator. It is showing what 1 unit is equal to. So let's get into our lesson. So let's read the instructions for problem number 1. It says that the total length of each tape diagram represents 1, and I circled that because it was important information. And then it says decompose, so pull apart, the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. The first one has been done for you. So if I take a look at this one, you can see that this is the shaded part, and they're telling me that that's equal to 1/2. Now, because it's starting off right away with this dotted line, it might be a little confusing. Just look at this solid line right here, and they're saying that this whole tape diagram has been cut up into 1, 2 equal pieces, and that's why we have a 2 in the denominator. Then what they did down here was they went ahead and they cut each one of these halves in half again. So now we have 1, 2, 3, 4 pieces, which is why now our denominator is 4 instead of 2. And what we can see is that I have 2 of these fourths make up 1/2. So all we're doing is we're really trying to show you how to decompose fractions into smaller fractions. So again, decompose, pulling apart. Instead of going into this one, because I think it being cut apart is actually kind of confusing. So I would like to actually jump down to example C, where it has not yet been cut apart for you. So again, they told us in the question and the instructions that this entire tape diagram is equal to 1. So I need to figure out what is just this one piece. So the first thing I want to do is I want to figure out my denominator. So I have 1, 2, 3, 4 pieces. So now I know that my denominator is going to have a 4 in it. And since I only have one piece shaded, I know that that's going to be a 1. So that's 1/4. Now what I want to do is, remember, we have to decompose it in a couple different ways. So I'm going to go ahead and I'm going to use my flare here for this. The easiest way for me to do that is just to cut each of these in half so that they'll become smaller. So remember, whatever I do to one, I have to do to the other, because the whole idea with fractions is that it's equal pieces, and I apologize that my cutting might not be perfect, but I'm doing it through the camera. So now if I take a look at this, I have cut them into smaller pieces. I'm decomposing them into smaller pieces. Now what I want to do is I want to figure out what's my new denominator. So I'm going to count how many pieces make up the whole tape diagram because I know that's equal to 1. 1, 2, 3, 4, 5, 6, 7, 8. So my new denominator for this one little piece right here is going to be 1/8. So my denominator is 8 because there's 8 pieces, and this is just one of them, so that's why there's a 1. And I'm going to have the same thing for this one. This one's also 1/8. Now I can stop there because that's what I have. That's the shaded region. So that's all the pieces that I have. So now what I know is that 1/4 is going to be equal to 1/8 plus 1/8. And if you remember from our previous lessons, I could even say that 1/4 is equal to 2/8. All right, let's take a look now because we were supposed to take that and decompose it in a different way over here. So let's see if we can figure out how to decompose that in a different way. So we already know that this is equal to 1/4. We did that already. And again, just to review, we have 1, 2, 3, 4 pieces. That's my denominator. And my numerator is 1 because one of them is shaded in. So now I'm going to decompose it in a different way. So before I cut each one of those up into cut them each once or cut them in half, now I'm going to go ahead and I'm going to cut them up twice. And I'm going to make 3 pieces out of each of them. Now if I do it in one, I have to do it in the other. And I'm making a whole bunch of pieces here. All right, so now what we have to do is we have to figure out what is the size of each one of those smaller pieces. And you could have cut them up into fourths or whatever you wanted, cut them into 4 pieces. But let's take a look at what these are. So again, the denominator is how many make up the whole, so I have to count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've cut each one of these up into a 12th. So I need to put a 12 in the denominator. And here I have 1/12. So I'm going to say that I have 1/12, and that's this guy. So I want to bracket it. And now this one, sorry about that, is also going to be a 12th. So that's going to be another 12th. Oop, I got a notification. And these are so tiny. And here's another 12th. And then just to make it a little clearer, I'm going to go ahead and put my addition symbols in between them like this. And what we know is that that is equal to what we started with before, which was a 1/4 when we had it divided into fourths. So I'm going to go ahead and write that that's equal to a 1/4. So now I know that 1, 2, 3 twelfths is equal to 1/4. So now I feel like you can probably do the rest of the problems on this page on your own. And just remember, first thing you have to do is you have to figure out what is the bracketed part on top by counting up the number of pieces that the whole was cut up into. Here's a hint. I see 5 pieces. My denominator is 5. And then you're going to cut it up in 2 different ways. So you might want to divide this one up into 2 pieces, or you could divide them into 3 pieces or even 4 pieces. Just know that it's going to get tighter and tighter and tighter. So let's go ahead and let's go to the next page and take a look at the next problem. So in problem number 2, it's telling us that the total length of each tape diagram represents 1. Decompose the shaded fractions as the sum of smaller unit fractions in at least 2 different ways. So now, instead of starting with a unit fraction, we're going to be starting with a slightly larger fraction. So let's take a look at the first one and figure out how we want to do this one. So let me first figure out what is my original fraction that I'm starting with. So if I take a look here, I can see that this is supposed to be 1 whole because it says it right here, that the tape diagram represents 1. And I can see that it's being divided into 1, 2, 3 pieces. So now I know that the denominator in my fraction is 3. But I have to ask myself, what is my numerator going to be? Well, since I have 2 pieces, I have 2 shaded, I know that my numerator is 2. So now I know that this is 2/3. So now I can take a look at this and I can say, well, one thing I know is that this is 1/3 plus 1/3 but that's not dividing it up. I need to decompose it into smaller fractions. So the first thing that I'm going to go ahead and do is I'm going to go ahead and just divide each one of those in half. I'm going to cut them into 2 pieces each. And again, you do that with the dotted lines. And now what I want to do is I want to show what each one of these represents. So again, I know the whole thing is going to be 2/3, and I have to figure out what is that going to be equal to. So again, to do that, oh, and I forgot to do this one. So I have to count up how many are there in the whole now. So including the dotted lines, I have 1, 2, 3, 4, 5, 6 pieces. So I know that each one of these is going to have a 6 in the denominator. And since we're doing unit fractions again, here's unit fractions, I'm going to put a 1 in there because that is 1/6, that's one piece. Now I'm going to add to that another 6th, and then I have another 6th, and then I have another 6th. And so what I'm seeing now is that 2/3 is the same thing as 1, 2, 3, 4 6ths. So now I have to do that in a different way. So I'm going to go over here, and again, I already know that I'm starting with 2/3. So I'm going to write 2/3, that the bracket is not one whole this time, it's 2/3. And now I have to cut that up into a different way. So instead of dividing each one of these into 2 pieces, I could divide it into 3, I could divide it into 4. So I'm going to go ahead, I like dividing it into 3 because that gives me more room to work with. And I have to keep going. Remember, whatever I do to those, I have to do to this one. And now I have to figure out what is the denominator going to be for each one of these smaller pieces. So I'm going to start out, I have my 2/3 is equal to, so let me count and see how many pieces I have in all. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my new denominator is going to be 9. And each one of those pieces is going to be 1. So now I'm going to bracket off the rest and show that this is also 1/9. And I'm going to show that this is also 1/9. And I want to remind you, you have to show that you're adding them together, that they're all part of this whole thing, because some of you were not doing that in your homework from the last lessons. So now I've shown that each one of these little pieces is 1/9 of the whole thing. And now I can show that 2/3, so this amount, the shaded part, is the same thing as 1, 2, 3, 4, 5, 6/9. Now I think that you guys can probably do this one on your own. So let's go down here and let's take a look at what they're asking us to do. And it says draw and label tape diagrams to prove the following statements. The first one has been done for you. So in the first one, what you can see is that the job was to prove that 2/5 is equal to 4/10. So if I need to prove that 2/5 is equal to 4/10, the first thing you have to do is draw a tape diagram and model the 2/5. And then you're going to have to change that 5ths into 10ths. So let's take a look at how they did it here. And again, I think it's confusing when they've already drawn all the dotted lines in there. So actually, I'm going to go down here and we're going to do one on our own. So if I take a look at this one, you can see that 2/6 is going to have to be shown to be equal to 4/12. So the first thing I have to do is I have to draw my tape diagram, and I'm going to do this looking actually at the page. And I'm going to make it a little bigger so we have some more room to work with. So the first thing I have to do is I have to cut it up into pieces that are 6ths. So I'm going to go ahead and do that. I'm going to cut it in the middle, and then I'm going to cut each one of these up. All right, and then I have to show that I have 2 of those. Excuse me while I fuss at my children. Shh. Yes, everyone's at home right now. So again, I know that each one of these is a 6th, and now I have to shade it in to show that I have 2 of them. And now I have to show my scale, that this isn't like a whole. I have to show that that's 2/6. And the way I do that is by bracketing it off up here. Now what they want me to do is they want me to turn those 2/6 into 12ths. I want you just to think for a second, how are you going to do that? How am I going to turn my 6ths into 12ths? And the best way to do that is to think, and I'm going to do this over here, how do I turn 6 into 12? What would I do to make that happen? And the other way you could think about it is if I went from 12 to 6, what would I have to do to make it smaller? How would I divide that? But think about it. 6 times what? 6 times what number is going to give you 12? And most of you should know that it's going to be 2, which means that I